For millennia and ages, humans have gazed up at the night sky, wondering always about our place in the cosmos and indeed its ultimate fate. Today, we confront the profound question, how will the universe eventually end? Let's explore the most astonishing, science-backed theories. Our first scenario, a potential fate for the cosmos, is the Big Freeze. Imagine a universe growing ever colder, sometimes referred to as heat death, a slow, chilling end where all energy dissipates. The universe is expanding at an accelerating rate, and dark energy, that mysterious force, is accelerating this process, pushing everything further and further apart. Over billions and billions of years, an almost incomprehensible span of time, galaxies will drift so far apart from one another, receding into the ever-expanding void. Their light, the very signals of their existence, will never reach us, lost to the vast distances. Star formation, the engine of cosmic creation, will cease as the available gas runs out, the raw material for new stars exhausted. Stars, the brilliant beacons of the universe, will eventually die, their fuel spent, leaving behind only stellar remnants. White dwarfs, the cooling embers of once great stars, neutron stars, incredibly dense and rapidly spinning, and black holes, the ultimate cosmic traps. These remnants, scattered throughout the expanding universe, will slowly cool and fade, radiating their remaining energy into the void, plunging the universe into an all-encompassing darkness, a cosmic night that never ends. Over unimaginable timescales, far beyond human comprehension, even protons, the fundamental building blocks of matter, may decay, their stability undermined by the relentless march of time, dissolving all remaining matter into a thin, ever-diluting soup of fundamental particles. Black holes, the last surviving structures in this desolate universe, will eventually evaporate, slowly but surely, through the quantum process of Hawking radiation. When the final black hole, the last vestige of structure and complexity, finally vanishes, only a cold, empty void remains, stretching out to infinity in all directions. No usable energy, no active processes, no recoverable information, just a silent, eternal night, an unending expanse of nothingness. This is the Big Freeze, or heat death, not a dramatic, fiery end, filled with explosions and cataclysms, but a slow, inevitable fading away, a gradual decline into absolute zero. Time itself may lose all meaning, becoming irrelevant in the face of such utter stagnation, in this final, frozen state, the ultimate expression of cosmic entropy. The universe's story, once filled with vibrant activity and boundless potential, ends not with a bang of destruction, but with a whisper of silence, a gentle fade into oblivion. An endless night, a cosmic darkness stretching on forever, an eternity of emptiness. Now let's consider a scenario that's the polar opposite of the ever-expanding universe we currently observe. Imagine the universe contracting, shrinking in on itself. This is the concept of the Big Crunch. It's a fiery, cataclysmic collapse, a cosmic implosion of unimaginable scale. If the universe's density is high enough, meaning there's enough matter packed into the cosmos, gravity could eventually halt the relentless expansion we see today and, instead, reverse it, pulling everything back together. Galaxies, once drifting apart, would rush together, drawn by the ever-increasing gravitational pull. The cosmos would begin heating up dramatically as everything contracts, the space between objects shrinking rapidly. The night sky, once a canvas of stars against darkness, would blaze with searing light, an unbearable brightness. This is because the universe grows denser and hotter with each passing moment, the energy intensifying. Stars and planets, the celestial bodies we know, would be vaporized by the extreme heat and pressure, reduced to a chaotic soup of fundamental particles, their structures completely broken down. Black holes, those cosmic vacuum cleaners, would merge, growing ever larger and more destructive. Then even they would be torn apart by the unimaginable extreme forces at play, the very fabric of space-time unraveling. In the final, fleeting moments, all matter and energy, everything that exists, would compress into a single, infinitely dense point, a singularity beyond comprehension. This is the ultimate singularity. The Big Crunch, in essence, is the Big Bang in reverse, a cosmic reset button, if you will. Could this singularity, this infinitely dense point, spark a new universe, igniting another Big Bang and beginning the cosmic cycle anew? The Big Crunch is not just an ending, it's a possible rebirth, a cosmic phoenix rising from the ashes of the old, a universe recycled time and again in an endless cycle of destruction and creation. Is this the ultimate fate of our universe, the end as we know it, or simply a new beginning in disguise? There's a third, more terrifying fate, the Big Rip. If dark energy grows stronger, it could tear the universe apart. Expansion would accelerate until it overcomes gravity, first ripping apart galaxy clusters. Galaxies themselves would be shredded, their stars flung into the void. Eventually, even solar systems would be torn apart, planets ripped from their stars. In the final moments, the Earth would be destroyed, its very atoms pulled apart. The forces binding molecules and nuclei would fail. In a fraction of a second, every particle would be isolated, unable to interact. The fabric of spacetime itself would be torn asunder. The Big Rip is a sudden, violent end. Everything, everywhere destroyed. No structure, no matter, no spacetime. The universe unravels completely. The end, in a final, definitive rip. What if the universe doesn't slowly wind down or meet its end in a fiery, violent collapse? What if instead, the end is abrupt, unexpected, and absolute? What if it all ends in an instant? Enter vacuum decay, a theoretical yet terrifying possibility that lurks in the shadows of our understanding of the cosmos. It's a sudden quantum catastrophe, a game changer on a scale we can barely comprehend. The unsettling truth is, our universe may not be as stable as we think. It may exist in what's called a false vacuum, a precarious state, like a house of cards on the verge of collapse. Imagine a lower energy, more stable, true vacuum exists, a state our universe could potentially transition to. Then, a random quantum event, a tiny fluctuation in the fabric of reality, could trigger the formation of a bubble of this new, true vacuum reality. And here's where it gets truly terrifying. This bubble would expand outwards, in all directions, at the speed of light, rewriting the fundamental laws of physics as it goes, leaving nothing untouched in its wake. No warning, no escape, utterly unavoidable. Everything in its path, every atom, every particle, would be instantly obliterated and replaced by entirely new physics, a new set of rules governing existence. Planets, our cosmic homes, stars, the beacons of light in the vast darkness, galaxies, gone in a blink as if they never existed. It's not an explosion in the traditional sense, but a fundamental phase transition of reality itself, a shift in the very essence of what is. The most chilling part of this cosmic horror story? It could happen at any moment without warning and we'd never see it coming, never even know what hit us. The universe erased from existence, replaced by something utterly alien, something beyond our current comprehension. Vacuum decay is the ultimate cosmic blindside, the universe's version of a rug pull, a sudden, silent end to everything we know and understand. Reality rewritten in an instant, leaving no trace of what came before. Let's revisit the Big Freeze through the lens of thermodynamics. The second law of thermodynamics says entropy, disorder, always increases. The universe is heading toward maximum entropy, perfect equilibrium. Energy spreads out, becoming less useful until no work can be done. Stars burn out, black holes evaporate, and all energy gradients vanish. The cosmos becomes a uniform, cold soup of particles. No temperature differences, no motion, no events, just stillness. Time itself may lose meaning as nothing ever happens again. This is heat death, not a violent end, but eternal stasis. The universe's story concludes in perfect, everlasting quiet. All energy spent, all processes ceased. The final equilibrium, an unchanging, silent void, the ultimate peaceful end. From the slow chill of the Big Freeze to the sudden shock of vacuum decay, the universe's possible endings are as humbling as they are awe-inspiring. These theories remind us that the cosmos is dynamic, finite, and mortal. Yet our ability to contemplate these fates is a testament to human curiosity. We are the universe's way of knowing itself, even as we ponder its end. Which theory do you find most compelling or frightening? Share your thoughts below. Thanks for joining this journey to the end of time. Like and subscribe for more cosmic explorations. Until next time, keep looking up.